Okay, so we're going to do two more examples to find area between two curves. If you notice, this is the back of the first page we just finished. It's the next example, and it says find the area of the region bounded by the graphs f of x equals 2 minus x squared and g of x equals x. So what's different about this one and the last one is that it doesn't give us those vertical lines that created our boundaries. So our boundaries are going to be based on the intersections of these graphs, and it'll make more sense when we draw a picture. So let's think about what these graphs would look like individually, and then we'll put them on a graph together. Well, here we know it's quadratic, and we know that it's reflected because there's a negative in front of the x squared. And then what does this 2 do? Think about if you rewrote it as negative x squared plus 2. We would know that it's reflected, quadratic, and shifted up 2, right? So we know it's going to look something like this with the vertex at 2. And then we know g of x is just a linear line with a slope of 1 going through the origin. So before I go put those on a graph together, I think it's beneficial to find the intersection points first. So I'm going to just make a note, so you have it on your example, is that we need to find intersection points So how do we find intersection points? Is by setting our functions equal, right? They're going to intersect when f of x equals g of x. By setting f of x equal to g of x and solving for x. So we're going to take 2 minus x squared and set it equal to g of x, which is just x, right? This is f of x, that's g of x. And now we're going to solve this for x. So where do you start to solve this for x? If you don't know, what's the strategy? You move everything to one side and you're probably going to factor, right? So you can pick either side. I like my x squared term to be positive, so I'm going to choose to move this to the right side. So then you have 2 equals x squared plus x, and I'm going to move over my 2, subtract it. So then we have x squared plus x minus 2. I should have wrote equals 0. I don't know why I didn't write that. And now we can factor this just using x method or product sum. And we say what multiplies to get negative 2 and adds to get a 1, since our middle term is a coefficient of 1. And that would be positive 2 and negative 1, correct? I always check and FOIL it in my head to make sure I would get what I started with, which I would. So then that makes my solutions negative 2 and positive 1. So that means these graphs should intersect at negative 2 and when x is 1. You could go ahead and find the actual points if you wanted to. You don't necessarily have to, but let's go ahead and do it. So I'd pick my easier function, which is this one definitely, and find my y value, right? So but my y just equals my x for this function. So then I know they're going to intersect at the points negative 2, and 1, 1. If you could check it in here, if you plug in negative 2, you should get negative 2, and if you plug in 1, you should get 1. So now we're going to come over here and actually draw both our graphs on the same graph, so then we can find the actual picture of our areas. Because remember, we need to know to use that formula we said in the last video, it's top minus bottom. So we need to know what would be on top and what would be on bottom. So let's draw our quadratic. We said we're going to go up 2, and it should be going down. And then we have our line that goes through the origin, over 1, up 1, over 2, up 2. Now I want to make sure I'm drawing this correct. So I'm going to go ahead and put those intersection points, 1, 1, and negative 2, negative 2. Which would be like right down here, let's say. And then that's a little funky, but it'll work. So this is my y equals x, or I could have said g of x because that was the function, and this is my y equals 2 minus x squared, f of x. I don't know why I put y. And so now that you have this picture, you should be able to see what area it's talking about. So I like to shade it in. We're talking about this area. If you notice on that last example, if you pause and go look at that last example, it clarified it wanted the first quadrant. Did it? Actually, I think I'm thinking of another example. Hold on. No, I'm getting... Never mind. That was another example that we're about to do next. Ignore what I was just saying about the first quadrant. But, so we want this area. Always check, does it stay consistent? Is the same function on top the whole time? Yes, it's this red function, our f of x. So we can set up just one integral. And so let's set it up. Our area is going to equal the integral. Now, how do we know our a and b, right? This is our a, and this is our b, which is these intersection points we found over here. -2 and 1. Notice in this problem we didn't really need these points. What you really need is the x value, but it sometimes helps to get these points just to get a good picture. So our area starts at -2, ends at 1, and then we do top minus bottom. So our top function is 2 minus x squared, and then you do minus, and then I always put the bottom function in parentheses, which is just x in this case, g of x, dx. Okay, so now we can clean this up if we can. There's not really anything you can combine. You just notice you don't really need these parentheses since there's only one term. So you can rewrite it if you want, or just keep it like that. If you like to rearrange it so it goes in descending order, you could do that too. I normally just leave it, but that's up to you. And so now we're ready to integrate. So this is again where I would pause the video and go ahead and just try to finish this problem, finish the integral, and get your answer, and then you can fast forward and see if you've got the same answer. But I'm going to show you just in case you need it. So 2 becomes 2x. Negative x squared becomes minus 1/3 x cubed. Negative x becomes minus 1/2 x squared. And then we have our boundaries. -2 is a and 1 is b. So now we're ready to plug in our boundaries. So f of b, let me just double check. Okay, so f of b would be 2 times 1 minus 1/3 times 1 cubed minus 1/2 times 1 squared, and then you have minus, and now f of b, which always put it in parentheses, 2 times -2 minus 1/3 times -2 cubed minus 1/2 times -2 squared. Now we're going to clean this up. That would be 2 minus 1/3 minus 1/2. I'm going to go ahead and wait to distribute that minus sign, or you can do it now, it's up to you. 2 times -2 is -4. -2 cubed is -8, so that becomes a positive 8 over 3. And then -2 squared is positive 4, so that becomes minus 4 over 2, which you could simplify that to 2 if you want, or wait, whatever makes more sense to you. Okay, I'm going to go ahead and distribute this minus sign now, so I have 2 minus 1/3 minus 1/2. That becomes plus 4 minus 8/3 plus, and I'm going to change that to be 4 divided by 2 is 2. Correct? Let me just double check. Yeah. Okay, so now we got to clean this up, do some fraction math. I'm going to go ahead and add my whole numbers together. So that's 4, 5, 6, 7, 8. And then you have minus 1/3 minus 1/2 minus 8/3. Okay, so again, I'm going to put my 8 over 1 and get a common denominator, which would be 6. So I'm not going to show all the math to get the common denominator, but I'm going to, I guess, draw an arrow up here and get them all to have a denominator of 6. So I multiply this by 6, so that'd be 48 over 6. This is multiplied by 2, so it becomes minus 2, 6. This is multiplied by 3, so minus 3, 6. And this is multiplied by 2, so minus 16, 6. So that all becomes, if you do 48 minus 2 minus 3 minus 16, what is that? I had it now. I don't. 27, correct? So it's 27 over 6 is your area. You could keep your answer like that, or if you did the problem on your own and you simplified it, you could have got 9/2 or 4.5. Either answer would suffice. And that is the area of this shaded region. So just keep in mind, sometimes they're going to give you your boundaries, and sometimes it's going to be based on whatever the intersection of the graph is. Okay, we are not going to do this example again. I might do it in a video. It probably won't be posted at the same time as these. If you want to try it on your own, it's sine and cosine. It's pretty challenging, but I'll probably post a video like in between days, maybe like Thursday, doing that one. But what I want to do is skip that one and skip the next one. Go to page 4. So you should be on page 4, and it says find the area of the region in the first quadrant bounded by y equals x, the line x equals 2, the curve y equals 1 minus x squared, and the x-axis. So if you notice, when they give you all this information, it's probably not going to rely on the intersection points as much. Hold on, let me find mine to make sure. There it is. But I always start by making sure I understand what each individual equation looks like graphed, and then finding intersection points, and then putting it on a graph together, just like we did the last one. So we know y equals x. X equals 2 we know is a vertical line at 2. And then 1 minus x squared, you might not know what that looks like. But let's go back to 1 over x. You should know what the parent function 1 over x looks like. Let me do a different color. Alright, 1 over x, y'all see this? Yes. It looks like this. And if you notice, we're in this problem, this is what I was referring to earlier, is we're in the first quadrant. So we don't care about this bottom one, we just care about that. So 1 over x squared is actually going to look pretty similar to that. It's just going to be kind of more spread out. But we'll say it looks the same as that first quadrant. So how do we put all this together? Oh, and the x-axis, right? So that's going to be important too, because it's going to give you your bottom boundary. So first we need to find our intersection points. Now what do you find your intersection points? You don't use the x equals. That's just going to give you like that's going to be a boundary. Because it's x equals, that's going to be an a or b. So we're not too worried about that. We need to take our actual y equal equations and set them equal and find intersections. So we're going to take x and set it equal to 1 over x squared. So you could solve this a couple different ways. You could put x over 1 and cross multiply, or you could multiply by x squared to move it to the other side. So then we have x cubed equals 1. So then you would cube root it. And so then we're left with x equals the cube root of 1, which is just 1. It's not negative 1. So they intersect at x equals 1. And if you want the actual ordered pair to know when you draw your graph, well, when x is 1, y equals x, so y has to be 1. Okay, so let's draw our graph. I don't know why I drew all that, because what did we only need? We only need the first quadrant. So I didn't really need to do all that. I could have just drawn the first quadrant. But I already drew it. So y equals x in the first quadrant. 1 minus x squared, we know looks like that. I'm kind of going out of order. I think it's easier if you draw your actual graphs first. And now we know this point where they intersected should be at x equals 1. because that's going to be important to make sure that it's in the right order, because then we have this boundary at x equals 2, right? I should have made this a different color. So you could draw it all the way up if you want. Oh, you could draw it all the way up if you want, but really you just need that little vertical line to show where you're stopping your area. So what is this the shaded region we created? It's because don't forget you're also using the x-axis, right? So it stops here. So we created this shaded area right here. Let me zoom in a little bit. Well, maybe I can on video because it's not zooming. You good? I'm waiting. Stay back. What? Sorry. Okay, so if we look at this area, we got to determine which one's the top and which one's the bottom. So I would draw vertical lines to make sure you're not missing anything. If you draw, when I drew these vertical lines, my top one here was my y equals x. My top one over here is my 1 over x squared. So your top and your bottom, well, your bottom's not changing, but your top is, right? Notice it's not going to be this function minus this function or vice versa, because the bottom is the x-axis. The bottom of this whole shaded region is the x-axis. And what's the equation for the x-axis? That's y equals 0. So your bottom is y equals 0. So we're going to have to split this integral up, right? Because our top function is changing. Where is it changing at? At this x equals 1, at the intersection point. You got to divide your area into two different sections. So our area, our total area is going to equal the integral of this first section starts where? At 0. And we're going to end it at 1. And now we do top, which is the red function, which is x, minus the bottom, which is our x-axis, which is just 0. So theoretically you don't have to write that, but I still want you to be able to see that we're still doing top minus bottom. And that was the first section. Now we got to add the integral of the second section, which starts at 1 and ends at 2. And now our top function is the blue function, which was 1 over x squared, minus our bottom function, which is still the x-axis, which is 0. And now again, you can pause here, go do all your integral and algebra work and see if we get the same final answer, but I'm going to go ahead and work it out from here. So I could rewrite this as, right, we don't need minus 0, so that's just the integral from 0 to 1 of x dx, plus the integral from 1 to 2, 1 over x squared dx. This one's ready to integrate. How do we integrate this one? You do not use natural log because the exponent on the bottom is not 1. You got to move it to the top using a negative exponent. So I'm going to go ahead and keep them on the same page. I'm just going to keep that one. Rewrite this one as what? X to the negative 2 dx. And now I'm ready to integrate. So the integral of x is 1/2 x to the, second power. I don't know why I was about to write 1/2. And that's going to have the boundary 0 and 1. Plus integrate this one, add 1. Would be negative 1, divide the coefficient, so it's negative x to the power of negative 1 with the boundaries 1 and 2. So now I'm ready to do f of b minus f of a for the first one, and f of b minus f of a for the second one. Maybe I should color code this. So that is 1/2 times 1 squared minus 1/2 times 0 squared. That's f of b minus f of a. Now I'm going to do the second one. So I have my plus. Now I'm going to do negative 2 to the negative 1 minus negative 1. I'm writing this with a lot of parentheses to the negative 1. Did I close all my parentheses? Yes. Okay, so let's see. This becomes what? Just 1/2? Now this is the one we got to kind of clean up. So what does the -1 do? Remember, it brings it to the bottom. So what are you left with? Is you still have that negative coefficient. So that's like a -1, right? So we have a -1 over 2. That's this. And then this becomes minus a negative becomes plus, and then that would just be 1 over 1. I feel like I did something wrong. Oh, no, sorry. I was looking ahead and thought I did something wrong. Okay, so then we have 1/2 minus a half plus 1. Well, 1/2 minus a half cancels out, so then you're left with just 1. Okay, so I think we're going to end it there, so let's recap. Let me find the first page. To find the area between two curves, you do top minus bottom, so it's either going to give you the boundaries based on whatever x equals numbers, or it's going to be where you have to find the intersection point, which is the one we just, this first example in this video, and that's going to be your boundary points. Or it could be a combination, right? And here the intersection points mattered because that's where it switched, and they also gave us a boundary. Look for those x equals, those are going to be boundaries. And then you do top minus bottom. So please let me know if you have any questions as you're working. You will have an assignment on AP Classroom just over this topic alone. And please, please, please ask questions or look up different resources online. I'm here to help you with whatever you need. So let me know how this video was. If you have any feedback on something I could do better or be more clear, or something just wasn't effective, let me know, because I want to make sure we're utilizing this time to the best of our ability. So good luck, have fun, because we all know how fun calculus is, and have a great rest of your day.